Well, good morning or good afternoon, depending on where you're located. Welcome to the Val-Matic webinar on air valves for the Canadian industrial markets. We're going to be strictly talking about the air valves for industrial, okay? The presenter today is Larry Woodworth, which is yours truly. And the organizers that we have is our regional sales managers. Mark Kinahan is the western part of Canada. Aaron Keeler is the central. And Mark Della Costa is the eastern part. So we'll be taking care of you today for the next 45 or 50 minutes. Now, before we get started, I want to do a little housekeeping, okay? As we go along, if you have any questions, there's a questions box. Please type them in there and send them off. And then I think Mark Della Costa is the one that's going to be answering the questions and sending the answer to everybody. So we'll take care of them as we go. If for some reason we don't, we do have a question and answer period at the end that we can answer any other further questions or anything that you may have. And that all, of course, depends on time as we go along. Another thing that's going to happen is you're going to get a follow-up email tomorrow. And that follow-up email is going to ask you what you thought of the webinar, give us any comments or whatever, which would be greatly appreciated. But also two other things in that email is one, I'm going to have a link to our air valve sizing program, which we'll talk about a little bit later. And we're also, is on there is each one of our reps, depending on what area that you're in, is listed there with their phone number. So if you have any additional questions or whatever, please contact them and they'll be able to take care of you very nicely. Now, I also have at the bottom, you'll see a little drop down for a handout. I do have a handout there. It's our brochure on the air valves. And you can print that off if you want to and kind of look at it as we go if you're concerned. If not, you can look at it later. The last thing I want to kind of go over is you will be seeing my cursor on the screen moving. I'm on one screen, so I have to run the seminar in the background, plus be able to take care of other things. But I'm also going to be using that cursor to point out things on slides as we go along to help illustrate what's going on. So it's a kind of a twofold thing that we're going to do here. So with that being said, let's take off and go to the agenda slide here. If I can get it to work. There we go. Okay, the introduction basically we just did. I'm going to give you a brief history of Val-Matic. Then we're going to go over our air valves, briefly talk about the other products that Val-Matic has, and then questions and answers. So in 1966, the company was founded by Andrew Nutter and Ted McCowan. And they started off with the silent check valve and the air valves. And from then we've grown. So we're 54 years company strong. So as the years went on, we added the dual disc check valve, a tilting disc check valve. We opened or built a brand new facility in Elmhurst, which is where our headquarters office and stuff is right now, our main manufacturing. Then we came out with our swing flex check valve, the cam-centric plug valve. And then we had to expand the facility in Elmhurst because we were growing so bad, so much. Then the rectangular cam-centric plug valve came out. And then after that, we acquired the American butterfly valve, which was the American darling butterfly valve. And then we came up with the surge buster check valve, which we'll talk about briefly later. Flood safe, flood preventer. Our AWOL water ball valve, which is very good in sludge applications and wastewaters and so on. So that fits nicely into industrial. And then in 2013, we acquired another facility in Addison, Illinois, which is about 7 miles away from Elmhurst. and that's for larger valves. So Elmhurst does anything up to 36-inch size, and then Addison does anything over 36-inch in size. And then in 2014, our last acquisition was the quadrisphere ball valve. So what we're going to do is we're going to talk about air valves. We're going to talk about the design and the different applications, kind of let you know where they go, how they're going to work, and so on. So first of all, though, I want to come up with our first polling question. And if you would answer it for me, so I'm going to pull this up. Then I'm going to launch this. Okay, so the first question is air valves are required in a pipeline to do what? Remove air, add air, or both? So kind of looks like we're getting a lot of people responding to this. That's good. All right. Very nice, very nice. And we'll give you another couple seconds to come up with that. Well, it kind of looks like maybe everybody is. So okay, we're going to close this out, and then we're going to share the answers. So here's the results of the poll. 42% said remove air, 3% said add air, and 55% said both. And the correct answer is actually both. And we'll kind of go over this, but air valves have to do two different functions. And once we start getting into this, you'll understand about adding air to the pipeline and how critical that is to do that, okay? So we're gonna get rid of that and we're gonna continue on here. So the types of air valves that we manufacture is the air release valve, which is sometimes called a small orifice valve, an air vacuum valve, or a combination air valve, okay? But let's just kind of talk about the Canadian standards right at the moment, since that's kind of a topic. Now, I do understand, talking to the reps up in Canada, that the end user can waive the requirements if necessary, or if, allowable type of thing. But according to the TSSA, this is what they told us about 2 months ago, is a pressure vessel fitting or piping that contains liquids not more hazardous than water, and that operate at a temperature of 150 degrees or less Fahrenheit, and at a maximum allowable pressure of 250 psi or less. Then they said, so from the description that we gave them in our design conditions, that the valves are exempt from the regulation, okay? Now, the ABSA said that the air valves are required to meet ANSI or ASME P1634 and the pressure vessel code, or the boiler pressure vessel code, sorry. And we don't meet those standards. We only meet AWA C512 standard. So, but here again, if the customer can waive the requirements, then you should be okay. So I know this is kind of the wrong place to put the materials of construction, but I wanted to put them up now because they're going to be the same for each one of the valves we talk about. So instead of talking about it after each valve, I'm just going to list them all and talk about them all at the same time. So the air release valve, the air vacuum valve, and the combination air valves, they all have the same materials of construction. So the body and the cover standard is cast iron, but we can do ductile iron or stainless steel. The trim and all the valves is always going to be stainless steel. So all the internals are stainless steel parts. As far as coatings, we can do, epoxy, bonded epoxies, internal, external. We can do fusion bonded epoxy, So, I mean, there's a lot of things we can do in case there might be chemicals or some other things going on with the media that's going through these air valves. So, as far as air in the pipeline, okay, there's three sources of air. One is the pipeline itself. Now, if you think about it, if you're filling a pipeline, it's got air in it. So you have to get that air out as you're filling the pipe, okay? The next one is the fluid, okay? Just about every fluid imaginable is going to have some kind of air in it. As an example, water alone has 2% by volume air in it. So you got to get that out. Now, mechanical equipment, that brings in a lot of air. Now, pumps, believe it or not, valve packing, flanges between the, like say, valves and the piping and stuff. Any place where there's some way air can get in, that could be a source of air getting into your pipeline. So there's, it can be a very big problem depending on what's going on. So the first valve we're going to talk about is the air release valve. Now, this valve continuously releases accumulated air in your system, okay? And that's all it does. It opens and shuts and opens and shuts and opens and shuts. So let's just kind of look at what we have here. Okay, now the first one on the left here is just a simple lever, and the one on the right is a compound lever, but they both do the same thing. Okay, as the fluid or whatever starts to come in, there's always air traps. So the air is moving out, being released. And as it released, then the fluid takes over, lifts up the float and shuts it off. And that's all it does. And then when more air gets in there, it drops the float, releases, float comes back up, shuts it off. So that's all it does, is just release air whenever there's a pocket of air at a high point. So this is one of the reasons why you have to have air release valves. Your high points in your pipeline, right, or anywhere else for that matter that the fluid's going through, your air is going to accumulate in these high points, okay? You have to get it out. If you don't, some bad things can happen to your system. So let's just say you don't get the air out of the high point. So the air collects in there. So the air collects to a point where it is going to choke off the flow. And then what happens is all of a sudden there'll be a large mass of this air forced downstream to the next high point. But it also causes a huge velocity change and a pipe surge and possible damage to something. So that's where you have to get, and the reason why you got to get the air out of your pipe. So here's just an example. These are air release valves in an Australian mine. And there's the circle, and they're all the way down the avenue here. But these are in around the pump stations and that to get the air out before it starts going down the pipeline. Okay. So the air vacuum valve. What it does is it exhausts air. As the pipe is filling up, starting up or whatever, you have to get the air out of the pipe. So what it does is it releases that large volume of air out of the pipe. Once it gets to the point where all the air is gone, then the system will shut it off and it'll hold until there's a shutdown, there's a failure, there's something. Then when that float drops back down again, it allows all this air to come back into your pipeline. Okay. So here's some illustrations for you. So when the pipeline is filling, it's open and the air is exhausting out the top. Once the pipeline is under pressure, that float lifts up and it shuts off and it doesn't move until there's a problem. So when you're starting to get draining, dewatering, whatever you want to call it, a failure in the system where everything drops. Once the pressure drops, then the flow drops and the air comes back in. So you don't create a vacuum in your piping system. So what happens during initial pump fill up, large amounts of exhausting air in your high points has to get out of there. So that's what the air vacuum valve does. And then, large amounts of vacuum protection and so on in case there's a problem of failure of, you're draining the line or whatever. So it'll separate, column separation at these points where it starts to create the vacuum or a negative pressure, because now that's draining on both ends, okay? It's going one way and the other, so you get this negative pressure build up here. And then all of a sudden, if those two columns come back and rejoin because of the vacuum, that's when damage is caused. A huge surge in your pipeline. You're going to get huge amounts of, similar to water hammer, but it's going to cause major problems. So that's where you have to have these air vacuum valves to get that air back out, okay? And then you're okay. So when things go bad, this is what happens when there's no air valves in a pipeline and you're draining the pipe. This is a 42-inch pipe, happens to be a water pipe, but there was no air vacuum valves to let the air back into that pipe, and it collapsed. Now, I've seen, large pipe and there's a lot of metal there and so on and so forth. And for it to collapse and look like this, that's huge. It's something that most companies don't want to see. Now here's another one, things go bad. Now, the one on the left here, I'm guessing that's around a 4-foot, 5-foot diameter pipe. And you can see how flat it is. Here's the saddles right here where it was, but it's now flat. And that was because there was no air valve and system failure, so did the pipe. Another thing that we have to think about is storage tanks. If you got a storage tank and you start draining it, okay, you have to allow air to come back in or it starts to collapse on you. Now, for those of you that have kids or grandkids or nieces and nephews or whatever, you've probably seen them, with these juice boxes, and they got the straw in there and they're, sipping on the juice and so on and so forth. But when it gets down to the bottom, they want to finish every little drop. So they keep sucking on that straw, and then all of a sudden that juice box collapses. It's the same thing. Or you could put your finger on the end of a straw and suck on it, and it collapses. And that's causing that vacuum, and that's what's going to happen. Now here's, I love this. This is a little video. This is what happens when you don't have an air valve, a air vacuum valve. Now, this every time I see that, I get a big smile on my face. So I'm gonna roll it again just for the heck of it. But what they were doing is they were draining this tank car, but they weren't allowing air to come back in, and it caused it to collapse. So here's all the audience to see what happens. And you can see no air valve, it collapses. So it's, it can be a dangerous thing and it can be a very costly item. So you got to make sure that you can get things like that out. So if we don't have any questions, I don't think Mr. Mark's got any questions. But anyway, let's continue on. The next valve we want to talk about is the air combination valve. It's the most commonly used of all air valves. Now, it performs both functions of an air release valve and an air vacuum valve in one valve. That's why it's more common, because it takes care of all worlds, so to speak. So if we go from left to right, The one on the left is what we consider a dual body, dual float combination air valve, where the center one here is the vacuum, and this one over here is the air release. One in the center here is the combination. It's a single body, one float. And what happens is when it's exhausting all the air, when the pipe is filling and so on, this piston that you see moving here stays up, okay? And then if air does come into the high point, as it goes down, there's a little tiny hole in this, I'm not sure what you want to call it, stem or whatever right here, that lets the air out. So that's the air release part of it. So it, but you know, it stays shut for most of the time unless there's air trapped in there, then it'll exhaust it. And then one on the right here is a single body dual float design, same kind of thing. So here's to illustrate it a little bit better. During the pipe fill, air exhaust, air exhaust, air exhaust, you got your piston here. And until all the air gets out, then it goes closed because now the pipeline is under pressure, pushes out the flow, it shuts it off. And this is your air vacuum valve part right here, okay? Then, if for some reason accumulated air continuously or it gets up in here, it will release it. And here's that little hole right here that acts as the release for any accumulated air, acting as the air release valve. And then last but not least, if for some reason the pipeline drains, there's a failure, something happens or whatever, that main part or that main seat or piston or whatever you want to call it will fall and let all the air back in. So you don't get that vacuum effect. So hopefully I'm not going too fast and I don't see too many questions here, so I must be doing okay. The installation of this is a combination air valve on top of a pipeline. And these are dual bodies. You can see the little one and the big two bodies right there in the pump station. And here's another pump station. As you can see, all the air release valves all the way across where the pumps are. So to kind of give you an idea, the difference between a standard air valve and like say a wastewater treatment valve or a sludge valve or a sludge air valve or whatever is on the wastewater air valves, the body's extended, and that's to avoid any fouling of the mechanism and stuff up here, okay? It increases the flow clearance. We have more clearance around the flow here than we do in a standard air valve type of thing where there's no solids, just because you don't need for that to lock up and become clogged, okay? And you don't need the flow to not be able to do its job. Then there's a little skirt down here to help any of that, when that rushing media comes in, it kind of keeps it from banging that float and helps prevent some excess clogging and stuff like that. So wastewater air valves. This is the air release valve here, the air vacuum valve, and then here's the combination of the two. So the centrifugal pump manufacturers, they recommend that release valves be put on the high point, the highest point of the volute of the pump to get the air out, because centrifugal pumps make a lot of air. Okay, it just happens. If you have a pump, you have some tanks. Probably the best one to put in there would be combination air valves. to let that air out of the tank because you don't want it to collapse. But also too, if something you need to drain the tanks or whatever, you need to have the air that comes back in. Okay. I see there are some questions going on, so good. I'm glad we're getting those answered for you. Some of the other types of air valves that we have is a well service air valve would be like if you have underground tanks or whatever, and you're going to be pulling the product up out of the tanks. This would probably be a good valve for that. Dual port throttling device, and basically this helps throttle the air coming out through the air valve and that, and it also does a nice little vacuum type of arrangement up here with the spring loading and so on. So we have that to go on. If I got into a lot of detail on this, we'd probably be another 20, 30 minutes. So I'm just going to kind of go through these briefly. Air suppression air valves, or surge suppression, sorry. Basically, if in your piping system, if you know you're always going to get surges, okay, from whatever the case may be, mainly air, this might be the valve to put in an application like that, because then it is set up to help reduce that surge in your pipeline so you don't get a lot of damage and so on and so forth. So it's a special setup, and we need, of course, to know all your combinations of what's going on and all your design kind of information and that kind of thing. And then a vacuum breaker, another one that if you always know you're going to have a problem with vacuum, your pipeline creating a vacuum to impair everything, then this one might be the good valve to put in there also in that application. Now we're going to launch another poll question here. All right. This is, are you having issues with meters or other devices in the pipeline not providing accurate readings? So I'll give you a little bit to answer those. Looks like we got just about everybody responding to that one. So I'm going to close this out, and I'm going to share it with everybody. So here's the answers. Yes and no are identical, and don't know is 57%. I mean, I've talked to a lot of people on sales calls and stuff, and they're saying, yeah, I just my meters, I can't get them accurate, and I don't know what's going on. The function is probably air before your meters, and if you got air going through with your flow, then it's not going to give you an accurate reading, because now you could have 2, 3, 5, 6% air in the media, and it's going to cause you some false readings. So let's hide this, and we'll go to the next slide here. So this is where you would put in front of a flow meter or any other kind of meter that you're looking at in your piping system, is put that air release valve right before it, okay? And that will help get rid of the air, okay? Because it'll bring it up out of the pipeline, so you can get more of an accurate reading with your meters. And it's a pretty, sometimes it's a simple fix, sometimes it's not, but it can be very beneficial. Especially it could be a cost savings if you're getting false readings and you're pumping too much or too high of a pressure or whatever, or you're not getting enough product. And that could help you settle things out a little bit and maybe be a cost savings to you. So here's kind of a typical, it says water and wastewater, but it could be any kind of, media, sludges, any kind of wastewater. I mean, there's wastewater in industrial plants all the time, as there is water in industrial plants. But if we look at this schematic, it would be hard for me to place the X's of where all the air valves would go, only because I don't know the piping system. So we have to remember that air valves go by the pipes or by the pumps. It goes in the high points of the pipe, okay? If you have meters and stuff, maybe before the meters. So in long runs of pipe, you have to have an air valve to make sure you get all the air out. So the brown lines serve as sludge lines, and the blue is your, clean water or semi-clean water. And it can go anywhere and everywhere. So, it's like I said, it's hard to pinpoint exactly where air valves would go, except that equipment, high points, those kind of things, is where they would get into. So here's one for, like, say, mining waste treatment. Okay. Here again, the blue lines are more of the clean fluids going through, and the brown are more of your sludges and stuff. Here again, it's hard to put X's all the places, but pumps, when you're tanks, high points, any kind of equipment, you've got to have, air valves to get a lot of that stuff out. So it's all over the place. So, if some guy is saying, well, I'm having problems with, this equipment down from the pump or whatever, and I don't know how to fix it, then, the question would be is, do you have an air valve? And if they say no, well, then, then you got to go, or if you're having problems with, something around a pump or, down away from a pump or on elbows or after, some kind of equipment, look and see, you might have to put an air valve in that particular slot to be able to get the air out, so you have more, flow and less problems and those kind of things. So our air valve sizing program, now this is the link that I'm going to send you tomorrow. It's for this program, and it's also on our website. And you can go there and fill all the details out. Now, what's nice about this program is it will ask you, 101,000 questions. But it's to properly, help you size air valves. Pressure, how many pumps you have, is it going to be close to a pump? How many feet of pipe, do you have? How many high points? Those kind of things. Size of your pipeline and that. Now, when you go in there and you take a look at this and you want to, start a program, log in with something. Now, I say that because if you get into it and you've logged in and you've got all the information in there and it's not giving you any kind of correct information, or you don't think it's correct, or you're not sure or whatever, what can happen then is you can call and talk to one of our engineers, and then he can go in from our system and look at your, information that you logged into and put in there and help you figure out what's going on. Okay. So to me, I've given this program to, Burns and McDonald, Kiewit, Black and Veatch, and their engineers just absolutely love this, especially to the point where, if they come to a stall or a little, question or whatever, you can call our engineering department and ask them to help out. So that's what's pretty neat about it. And like I said, the link to this will be on that follow-up email you'll get tomorrow, and it's on our website also. So I just briefly want to touch base on other products we have. Some of them have Canadian registration numbers and some don't, but there might be, cases where you might need something. But our family of check valves, we'll start up here. This is our swing flex check valve. It's a great wastewater and sludge valve. We can rubber line it to give it some, longer lasting life in there. We can do all sorts of things to it, but it's very simple. It's a one-piece movement. It's got a flapper, and it does very well, like I said, in wastewaters and sludges and that. Then we have our dual disc check valve, all sorts of different applications that can go into. Then we're going to look at this valve here in the middle, which is our surge buster. Now, basically, that's the swing flex for the spring in it. And that's to get that to close very quickly, because the last thing you need is water hammer in your system. Okay. The valves over here are our inline check valves. Then we have our tilting disc check valve. And then this is the flood safe, not this flood safe, but I'm not. Check valve that they use for, like say, pulling water out of rivers and stuff, because it's got a filter type of thing, a basket or some kind of sieve or something down here to eliminate the products and stuff getting up in there. We're already talking about the air valves, so we're going to skip that. Then our quarter turn valves. The one up here at the 12 o'clock position is our butterfly valve. That's very versatile. It's good for water intakes, and that it can be any kind of coatings on the inside. We can rubber line it, and that. So, and we go all the way up to 144 inches in that valve. So we have a big range in there. This valve over here is our energy ball valve. It's good in wastewater applications. It's an AWA standard, but it flushes itself out when it opens and closes because of the design of the ball and that. But it's very good in those kind of applications. Our plug valve, here again, is an excellent valve in wastewater and sludge applications. Okay, it's got, we can rubber line it, we can glass line it, and I forgot to say we can glass line our swing flex check valve too, in case there's chemicals or something involved. So it's great for those kind of applications. It's very rugged. It'll last forever in sludge or wastewaters. The last quarter turn valve over here is our quadrosphere ball valve. It is a API 6D pipeline ball valve that has been redesigned in the ball and seat area and that to be able to take abrasive solids, those kind of things, and flush itself out. And we're using these as one example out in the oil sands a lot. And they're working very, very well as SAGD valves for SAGD applications. So that's kind of our all the valves and stuff like that we have in the family of valves. And a lot of people don't like this, but I just want to point this out because we do have a lot of information that you can find on our website. Besides brochures on all of our different products and so on. Technical information, every product has technical information for that product. Application bulletins. We write a lot of application bulletins for different applications to give you an idea of what the application is that you might have similar or the same, what was going on, what we did to solve the problem. Okay. Videos. We have videos of different things that we do for valves and check valve comparisons and so on. Our drawings on the website are either CAD or standard sales drawings that you can print out. Instruction manuals for any of the valves. Case studies. We do a lot of case studies where there's a specialized application customer had problems with. We went in and we were able to solve the problem. So we have those on there. Valve specifications, white papers. We've got a ton of white papers on there for different things. The air valve sizing the energy cost calculator, certificates. And the one thing that's not listed on here that I have to add is all the webinars that I put on, we put on our website, and they are also in this area under resources and that. So there's a webinar in there on our Quadrasphere Ringmaster ball valve, and one for butterfly valves and air valves, another one for air valves, and then there's one for our plug valves and our swing flex and surge buster valves. So if you want to go in there and listen to those, you feel free, no cost to you. You can go in there and listen to those webinars also. So that kind of brings me to the end, to questions and answers. And I see Mr. Mark has been doing pretty well keeping up with everybody's questions and stuff over here. So if you have any more questions while we have the time and the space, please type them in. We can.
And Larry, just really quick, this is Mark. Anyone who put in a question, thank you. Thank you for attending. I apologize. It's I'm not used to answering the questions, and it's very small print. So hopefully I got everyone who submitted one. We will give you a reference point that you could send these questions. We could give you more detailed answers. I know they were kind of short responses, but thanks again for participating.
Right, and just to let you know, my email address is on the response that you're going to get tomorrow. If there's any questions that we haven't answered, or you would like more of an explanation, just send me a quick email and we'll get those sent out, and I will copy everybody on the answer. So everybody gets to see what the question was and what the answer is, okay? So we don't want to leave anybody, hanging in the dark, or, feel free to call your local rep with the numbers and stuff that were provided there for you. And you can, ask them the questions also. Okay. So if that's it, and nobody else has any questions and that, then I'm going to sign off for today. And I want to say thank you so much for attending. It's hopefully we were able to explain things to you, and it gave you a little bit more knowledge, but we're here to answer any further questions and to help you out on anything. So again, thank you for attending. We appreciate it, and hopefully we'll talk to you soon. Thank you much. Bye-bye.